Hello? 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 Oh my gosh. This is my back-to-back talk. I just did the What's New in C# and VB talk. And so I'm still on the adrenaline rush from that talk because it was just, oh, it's exciting. Everybody's excited to be there, and I was excited to be there. And so at about 15 till the end of this talk, I'm just going to slowly crash from that rush. Who was at that talk? Is anybody? Okay, so you were all the ones that were going out when where people were asking questions. Okay, you guys were all coming up here to make sure you got seats. So in that talk, we talked briefly, very briefly, about .NET analyzers built on the .NET compiler platform, which is a piece of this giant thing called Project Roslyn. The thing I put Roslyn in quotes because often we still think of Roslyn, and people still talk about the thing called Roslyn because it's much bigger than an API set. It involves the compilers, it involves the IDE stacks, it involves the scripting and REPL, and so it's a much bigger thing. And it's also the name of our open source project on GitHub, right? So Roslyn is still alive and well, but what we're talking about very specifically here is this thing called the .NET compiler platform, which is the API set that we built on top of the C# and Visual Basic compilers to allow you to do introspection of source code, transformation of source code, really so that you could write smart things that deal with source code, with C# code. So my name is Dustin Campbell. I've been on that project for too long. No, not really. It's so much fun, but it's been since we kind of kicked the thing off about 6 years ago. We finished up Visual Studio 2010, and I moved very quickly over to start working on this reimagining. And then during that time, we shipped Visual Studio a couple more times, and we weren't in it. But here with Visual Studio 2015, we are in it, right? It is there. It is a real thing. It's alive, and the notion of analyzers and code-aware libraries that we're going to talk about today, and we're going to build today, are in the box. So how many people here, just let me get a show of hands, just because I want to set a temperature of the room, because I don't really have a plan. And I want to get a sense of what people are interested in. I was talking with some folks over here, and they had some ideas. How many people have tried to build a .NET analyzer? Okay, so like a small handful of you. Klaus, yes, I know you've built an analyzer. But how many people here are just interested in, like, I want to know how to build these things, I know what it is, I want to get involved and start working on that? Hands? Okay. So we're going to I want to try and present this as something for you guys, okay? So if you build an analyzer, I'll try and go really, really deep, but what I want this to be is I want this to be a talk where we spend most of our time in code, away from slides. I'm not going to show you big syntax tree diagrams or all of that or theory or that sort of thing. We're going to sit down, we're going to write code, and we're going to build some analyzers, okay? So I said this last time in the last session. They put these slides at the front for evaluations. If you're in a bad mood right now, you can wait till the end. I'm fine with that. If you're feeling pretty good, go ahead. You could snap it right here, but seriously, don't give me a bad review right now. That's just mean. All right. So, what is a code-aware library? This is a name that we are attaching to a very important feature of. It's a feature that gets exposed in Visual Studio 2015, but we expect this to be something that we build upon for years to come. The idea of a code-aware library is a library that provides guidance on correct use through embedded tooling and operates on the user's code in real time. Okay. So imagine you take a library, and that comes along with all of the extra bits and pieces it needs to have an editing experience that helps you use the library, use the APIs. In this iteration of that, for 2015, that means analyzers, which produce things like squiggles in the editor, in the error list, and may break your build, that sort of thing on the build server, very FX cop sort of thing. It includes fixes for those, so you can create fixes that go along with them. In the future, this might mean custom IntelliSense. If you have a stringly typed API that takes strings, for example, or has some notion of convention for type names, say like an MVC where you have controllers and that sort of thing. You want to make a custom IntelliSense. You can imagine all sorts of things here. Custom formatting rules for how you format calls to my APIs, all that sort of thing. That's not in the cards right now, but that's in thinking for later. We want to take this idea of code-aware libraries that embed their tooling in the library itself or in its delivery mechanism, in its packaging, and take that a lot further. So that's kind of the vision, okay? So let's talk specifically, though, about .NET analyzers. Again, they're built on the .NET Compiler Platform APIs. As we built this system, we wanted to make sure that we could do this also in an efficient way. So the analyzer APIs are designed to run during compilation, as compilation happens. Whether that's at the command line or it's in the IDE, compilation is happening all of the time incrementally, essentially, as you're typing in the IDE to make sure that you can get to IntelliSense after pressing a dot, or squiggles to show up in a timely fashion. So while that happens, as the compiler does its actual phases of compilation and binds identifiers and does all of that work, it calls out to .NET analyzers so that we aren't doing work twice. Right? So you don't have to write an analyzer and say, okay, tell me about this thing. No, instead, the compiler comes and says, all right, I've cooked all of this up. Now what do you want to know? Right? So we can do it efficiently. Today, they can be distributed via NuGet or V6. A V6 is a Visual Studio extension. There is a project template that you can install with Visual Studio that through the extension manager that will allow you to create one of these, create projects for doing these easily. But when you write a NuGet analyzer, the cool thing about that is because through the magic of package restore, it flows with your code through source control into the build server, wherever that needs to be. So if you track your dependencies, if you express your dependencies in your project with NuGet packages, you can get analyzers to just kind of flow through the entire system that way. And so that's why that's very attractive. V6 is kind of for things that maybe you don't want it to go through the whole system. Things like I wrote a project called C# Essentials, which is just helping guide you to using C# 6 features, but they're not necessarily the sorts of things you'd want to error on the build server, right? The things like, hey, did you know you could use an expression-bodied member here? That sort of thing. So that one works really particularly well as a V6. It's also something you wouldn't want to add to every project. You'd want to have on all the time. So there's a couple of different delivery mechanisms, and they have different reasons for using them. Now, .NET analyzers are used to enforce best practices, and so in a lot of ways you can think of it as kind of the spiritual successor to FXCOP. And in fact, the team that's responsible for this, we built several of the kind of the highest valued, went and did a bunch of research and picked out several of the highest value FXCOP rules that really get used a lot and add the most value into the projects, and converted those to .NET analyzers. And so those are up on NuGet as well. So you can grab those and use them today. And as I said before, .NET analyzers may include code fixes. Those won't happen on the build server, but they happen in the IDE, and they show up in the little light bulbs, and they have a really great experience around them. Okay? So, as I mentioned before, I kind of cast the vision. Library plus analyzer and fix, that is a code-aware library. Okay? And that is all the slides I've got for you. Yay! Man, you guys are easy. Okay, so if you were in the last session, I apologize that I'm going to have to show this again. I need to show it again to just kind of set this up for everybody who hasn't been here. Because we have such a large room, I wasn't expecting to have such a large room. I'm really, really delighted that there is this much interest. But that means that I wanted it to be a little bit more interactive and talk about what we wanted to build and maybe build it on the fly. But instead, I'm going to have to pick something to build. And what we're going to build is a set of guidance for immutable arrays. Now, before we build that, I want to show a couple of things that I think are instructive. Let's dig into. Let's look at some other stuff first. So we're gonna go and build an analyzer in a little bit, but I want to show you what it looks like when you've got one in the product. So this is a fun project. If people have seen my talks before, they know that I like to do. I like to show off Z machines. Anybody? Nobody knows what I'm talking about. Yes. One person. The Z machine was it was a virtual machine, perhaps the first commercially available commercial machine back in the early 80s for running text adventure games written by the company Infocom in order so that when you wanted to produce a game, a text adventure game, you know what I'm talking about, go north, go south, pick up the sword, kill the troll, that sort of thing. And so when they wanted to create a game, they would create a game file that was the snapshot of initial memory for the virtual machine. And then they would just create a VM, a different VM for every machine they targeted. Because back then, if you wanted to have, broad reach of the consumer base, that meant you were writing for the Apple II, you were writing for the Tandy, you were writing for everything, right? The Atari. So you needed to have a broad set of machines available. So this helped them with development. This is my Z machine. Well, I've gotten several of these. This one is pretty glorious, I personally think, because it's a full debugger that I wrote for this. I'm a little crazy, so if I F5 and run into this, then you can see we're in Zork. All right, it's just the code base. I'm totally, this is self-serving right now. But I can open the mailbox, hit a breakpoint, step around through the code, all that kind of thing. But this works and it will run the whole games, all these games. So this is just my code base that I want to look at right now and look at some analysis. Now, I've gotten here, whoops, I deleted something. I've gotten here, I have installed C# Essentials. C# Essentials is an extension that I've written for Visual Studio 2015 to give you a set of analyzers, just a very few, like 3 analyzers and a refactoring, to allow you to basically point out and transform code that could go to C#6. A C#6 feature could be used. If you want to find it, you can go to the extensions and updates from the tools menu, search for C# Essentials. And it's right here. We were using it in the last session. Mads was using this in the last session to convert features. And so in my error list, I actually should have tons of problems. They're not actually problems. This is guidance given to me through this V6 that's installed in Visual Studio. This is not part of the compiler, but there are literally 800 and some things that I could do in this project if I wanted to use C#6 features, right? Now, this error list is something we completely rebuilt for Visual Studio 2015 to make it scale to the several thousand errors and warnings cases to make it easier to work with when that happens so that the sort order makes sense. You get hopefully you get the real error up on top that's causing all the rest of the errors when it comes to cascading situations. We've done a lot of work here to make sure that it's very efficient at loading lots and lots of errors because in this release, with the release of analyzers, we're going to do a lot more of that. Now, if I come down to the bottom of this thing, I'm actually going to see some of these show up in the editor. You'll see that certain things are grayed out, kind of faded out, because this is a case where I've got an analyzer that's doing that, that's saying fade this out right here. Because this, if I hover over, says, consider using an expression-bodied member here. And I could use the new C#6 feature that allows me to kind of use the double arrow or the fat arrow to produce an expression-bodied member. I've added a fix for it. So when I look at the fix, you see it right here. And you see this kind of diff view. What's very cool about this and very subtle is if you notice in that diff view, the red part, those are grayed out there. This is actually, what this is using the Roslyn object model, because it's immutable and it's an immutable snapshot, the way I create a code fix is I create a new version of that in the future, at some point in the future. I create some speculative version, kind of fork off and do something else. And so the features, though, can run on that entire object model, even if it's in the future. So what you're seeing, that graying out there, that's actually the analyzer itself running in the preview window. Right? It's not like we just took a bitmap. It's actually the real thing. That's actually an editor hosted in there, and it's running right there. But you can see what it's going to do. You get all of this for free when you write a code fix. I can apply it, and it goes away down below. I can also write code fixes so that they can fix at various scopes. So I could say, well, fix everything in this document, and look at a preview of that, and watch my line count drop by about 40 lines code. So this is the sort of thing that you can do with a code fix. Now this one is installed, again, with V6. There are several, that's one way of distributing and packaging these. But I think the preferable way, and the way that most people want to distribute them, is through NuGet. And this is a great way of doing it because you can ensure that you can have your own NuGet packages that are used at your companies, on your build servers for your own guidance and your own particular things that you want to make sure that your developer teams are adhering to the best practices that your team enforces. And then also for things that are out there, that are common libraries that people use, when they go get those from NuGet, I want their tooling, I want these squiggles and analysis to come down with it. So back to this, popping the stack. I apologize again if you saw this in the last hour, but the idea here, this code, it's pretty simple. What it's doing, most people can see what it's doing. You new up an empty array, you new up an array with 5 elements, and you print the length of each one, okay? Very simple. And when we're new to C#, we're new to .NET, this is the sort of thing that we grow to understand, and this becomes very common, and this is how we see our world, right? And so nobody's very surprised about that. Now then, what happens though is we introduce a new library. And you've got all these ideas in your head about how things work, right? And we introduce something that's conceptually very, very similar to something that you've been working with for years, like arrays. And so the thing I'm going to refer to is the system.collections.immutable package that we released with a set of immutable collections. It's got dictionaries and lists and things that are all done in a very immutable style so that when you add to them, you get a new one back, right? And there's a lot of sharing of items between them, but you get this kind of snapshotting behavior that's very popular. But when you use an array, you would think that you write it in very much the same way. So here's the code. So A1 down here is very similar to A1 up here, right? You just new one up. You assume it's going to be empty, right? Down here, you new one up and you put a collection initializer. It looks very much like this. You would assume that's going to work. But in reality, if I F5 this, it will, well, it'll do nothing because I didn't run that code. I heard a chuckle. You guys love to watch me fail. All right, so in this case, though, it explodes, like badly, null reference exception, and it's not at all clear why. In fact, it's very subtle why this explodes. The reason is because immutable array itself, the reason it was, its purpose for living is that so that it can wrap around an existing array and offer you kind of an immutable interface into that array, so a read-only sort of way to talk to it. And it's got add methods so that when you add an element to it, you get back a new immutable array. Now, because we wanted to keep the overhead very low on this, it's a struct. So all structs have public parameterless constructors that basically create the struct with everything nulled out, right? Just as if you said default of that struct value. It's the same thing if you knew it up with its public parameters constructor. It's just kind of one of the costs is the design of using a struct. And so in this case, there is no array in it right now. And so it explodes. If I look at this A1, it actually says it's initialized. And then trying to drill into it, it explodes even in the debugger. So this is something that, an API that should tell you, don't use me this way. This is a bad idea, right? It's not what you want. It's not what you're expecting it to do. The sort of thing that we would normally bake into the compiler, right? And put an error right there. Say, don't do this. This is not what you want. It's never going to work, right? Interestingly, on the next line, so if I were to say, I think I just comment this out, and carry on with it and continue. On the next line, I will also get a null ref. Because in this case, again, it's going to call the public parameters constructor. But even if it didn't, it would still do the wrong thing. Even if this worked, even if the public parameters constructor actually constructed for me an immutable array that was just a 0-element array, it would still fail because the collection initializer in C#, all that does is compile down to a sequence of add calls to an add method. And the add method on an immutable array doesn't affect that immutable array. It returns a new one. So what you get at the end of a collection initializer is still an empty array, right? So this very much also does not do what you think it's going to do. Wouldn't it be great if this API came along with that guidance with those errors? So just yesterday, I threw a NuGet package up here. I need to look at my all list. And we'll say a couple of keywords. Whoops. That's not going to give me anything. There we go. So I put up a package called CoreFX analyzers. CoreFX analyzers has 2 analyzers in it to detect exactly the cases I just showed you. So these are things that cost you, right? Because they happen at runtime. They don't happen at compile time in the editor when you're typing. So they cost you time and money, and they're problems, right? And they cause you to go and debug and figure out and go, oh, whoops, yeah, duh. And then you're mad at me because the compiler didn't tell you, right? So instead of you getting mad at me, we'll install this NuGet package. And immediately, or close to immediately, after things kind of refresh, we get squiggles. All right, they just start showing up here. And in the error list, there are 2 squiggles. They say, useful things. Do not use immutable T constructor. It doesn't tell you why. We can make it tell you why. There are facilities in the NuGet, in the analyzers to let you add more descriptive text here. But do not use these. Do not use a collection initializer with the immutable array of T. In fact, let's go ahead and give you quick fixes to show you, to guide you to the APIs you should have used, right? So instead of newing up an immutable array, instead go and use the .empty property, which gives you back an instance of immutable array that has no elements, right? And so we can do that. And then we can come over here. This one's a little bit more complicated to write the code fix for, but instead of using collection initializer, instead call create range, passing in a new array that will be used as the array inside. There we go. And now, if I run this, things work fine. And wouldn't that have been a lot easier than seeing it happen at runtime and not hating me? That would have been a lot easier on me, right? If you guys got this to see this. So what I want to do now, so this kind of setting up what the problem space is, and I want to show you guys how to build these. You want to see how to build these? Yeah. Okay. So what we're going to do, we're going to go and create a new project. I have gone and installed this, actually. Let me show you. Again, it's in extensions and updates. I've gone and installed the .NET Compiler Platform SDK templates. I also went and installed the Visual Studio SDK for 2015 RC to go along with this. At the moment, the Visual Studio SDK is being itself broken up into NuGet packages. And so this is going to change. This idea that you have to go and get this MSI for Visual Studio SDK and install that, that is going to change. So that you don't have to install that. You can just install this package. It will have dependencies on the Visual Studio SDK packages. So I install this, and that gives me what I need. Now, before we dig into actually building it, though, let's take a look at these lines of code and what they actually look like. There's another tool there that was right under. Just bring it back up. There's another tool that is essential for this, and that's the .NET Compiler Platform Syntax Visualizer, which is a tool window to install into Visual Studio that lets you actually see the syntax trees underneath and all of the guts of what the Roslyn object models underneath. And that shows up under View, Other Windows, Roslyn Syntax Visualizer right here. I've already got it up. So I come over here and click, and this gives me a view of exactly what I'm seeing. So here's the local declaration, and I can dig into the nodes of this. The one I'm looking for, I want to get into the variable declarator, into the equals value clause, and that's what I'm looking for. The object creation expression. These names of these types, these are nodes in an AST, an abstract syntax tree, these are nodes that have names that match the names in the C# grammar. We designed it that way. So if you have the grammar up, if you have the C# language spec, you can look and go, yes, I need an object creation expression. And then you go over here, you'll see a node, object creation expression. So they match up. But that's exactly, but you don't even have to know that. You just need to look, right, in here. In fact, this has got some real goodies if you right-click. Pro tip on this stuff. So I can say view directed syntax graph. And then it'll actually bring me up a graph, DGML, showing me the subtree of this whole thing, right, which is super cool. I can also come down here to the other local declaration, poke inside, and see the invocation expression. Let's see, simple member access, down into the argument list. No, over here. Where are we? Right here. There we go, the collection initializer expression, right? This is the other thing that we need to look for. So what I'm doing now is I'm kind of getting a sense of what the syntax tree is underneath the code that I need to go and start matching and looking for in an analyzer to kind of reduce so that I can find the pieces that I need to find and analyze them so that I can know where to show a squiggle. So I can view a syntax diagram for this, and things can get very, very complicated. So this is a super useful tool. Then I can also go ahead and I could change the code back to the way they're fixed and look at that and see, okay, here's what I need to do what I need to transform it into. Okay? So there's a couple of tools that are really helpful here. Now, let's leave that code right there. Let's go ahead and create an analyzer. So I'm going to create an analyzer with a code fix. This comes from, again, from that extension that I installed. And we'll call this immutable analyzer. This is grabbing NuGet projects right now, packages right now, and coming in. It also creates a test project to go along with it. Candidly, though this is recorded, so it's not candid at all, I don't really like our test project, and so I threw up a Roslyn NUnit Lite package that you can use for doing if you want to do NUnit testing. I was going to throw up an XUnit one as well, just you know. This creates for us, though, right out of the box, it creates for us an analyzer, a diagnostic analyzer, and that's defined as a class that descends from diagnostic analyzer coming from the Roslyn API, and also exposes it with this attribute, so it identifies itself. That will get loaded by the compiler, and it also creates a code fix. Now, when you create an analyzer, there are some decisions to be made. First of all, it doesn't matter what language you want to build it in. If you're a VB person and you want to build, code fixes and analyzers that work for C# and VB, that's fine. If you're a C# person that wants to do it for C# and VB, that's fine. I haven't tried it, but you could probably do it with F#. It's probably fine. It's all .NET code, right, at the end. So it doesn't matter what language you use, but determining your target language may have some decisions you want to make. And what you have to kind of think about your analyzer and what it does to kind of determine how language neutral or language agnostic it can be. There are facilities for analyzing things in a way that you could make it work on C# and Visual Basic, for example. If your analyzer gets very, very sophisticated and starts needing to look at a very high fidelity representation of the C# code or the Visual Basic code in the Roslyn APIs, then in that case you might have to split it apart, share some code, that sort of thing, if you want to do that. But there are various options you have available to you. This one in particular, kind of looking at the anatomy of a diagnostic analyzer, the most important method here is the initialize method. And that gets called with this thing we call a context. And basically what this is a way that you can get at interesting information at this phase, and the way that you can hook up other events to perform analysis so that you want to be called on. So for example, I can dot into this, and I'll see a number of registration methods. And these are ways that I can kind of hook up an event or a callback to be called by the compiler when it's time to do one of these things. And so there's various concepts here. There's code block, which is when the compiler is going to actually do something that would contain a piece of code. So you would think a method body, curly braces, right, that sort of thing, where there's actually a block of code. But also other things like the initializer of a field, or the value given to an attribute, or the value given to a named parameter, for example, or an optional parameter. Those sorts of things are where code block happens. There's also compilation. And that's where it's going to do the entire process. It's starting the entire compilation process. And what these are useful for are sometimes, if you want to get really nitty-gritty on the syntax, but also at compilation, you can write things if you want to collect some state, right? Say I want to go and find all of the unused fields, right? Well, in order to do that, you're going to have to do a fair amount of analysis, right? So you're going to have to, at the start of a compilation, you would create some sort of data structure to go and store all the fields in, collect them all at the start, and then or to create the data structure at the start. Then you would register actions to go through and look for all the field usages. When you found them, you would put them in that data structure, and then you would register a compilation end action. And when that happens, you would go and do the analysis, compare the data structure, and say, oh, okay, here's all the report diagnostics for all these unused fields. Okay, so depending on the scope and the breadth of what you're trying to do, depends on what you want to do here. you can get pretty far, we found, with symbol actions. Symbols, there are two representations in Roslyn kind of the universe. There's a syntax representation, which is really like the nodes in the tree. It really relates to a source file, right? It's got all the white space, it's got everything in it, all the comments, all the nodes, all the code. But then there's also a symbol version of it, like a symbol table where the declarations go, the types, their members, that sort of thing. You can almost think of it as a review that looks like if you were looking at reflection. And you were looking at method infos and types and that sort of thing. That's what symbols look like. Symbols tend to be very language agnostic. And you can do a lot. You can get pretty far with symbols. In fact, a lot of the FXCOP analyzers, which do things like verify that if I've got iSerializable as an interface I'm implementing, and I haven't added the serializable attribute, add a warning and a code fix to add that serializable attribute. That's something, that analysis, creating that squiggle, is something that could be done in a language agnostic way on symbols, and it will work for both C# and Visual Basic. The code fix itself, however, because now you're getting into source code and the shape of how the code actually looks, and that's very, very different, that might have to be written separately. So what we're going to do, this is kind of a silly example. I'm going to delete a bunch of boilerplate. I don't want to do any of this. So what it does is it gives you some boilerplate right up front, so that when you, basically what it does is it says, oh, you have types that don't have uppercase names, or uppercase letters, or have lowercase letters in them, and flags them with warnings. That's the boilerplate code, and then it gives a code fix to rename them. We don't need to run that. We want to do something more interesting. So what we're going to do is we are going to register a syntax node action. Now, the syntax node action we're going to register, because I want to do this analyzer to say, if I'm newing up an immutable array of t, and I'm using the default constructor, give me a squiggle. That's what I want to do. So I'm going to look for the object array expression. And so all we're going to do is come in here and say, I used the syntax visualizer. I saw what that looked like. Whoops. So I'm going to register syntax node action. And that gives me an opportunity to add a delegate in here or a lambda expression to say, here's what I want to do with this. Here's what I want to be called. And usually what I do here is I will actually often add a lambda, and then I'll put some method name in here to be called afterwards. So analyze, object creation. Actually, this is not going to be called like that. These are actions that get called with another context. And so I'll pass that in and call it here. And then, as the very last argument, we create a list of the syntax kinds that we want to look for. So there's a new enum in Roslyn on both C# and Visual Basic called syntax kind. It's a very important one because it's crazy huge. It has everything. Okay? And so this is where I'd say, oh yeah, if you run into an object creation expression, call my guy here. Okay? And so I'll use generate from usage to just generate that for me. I'll call this context over here. And this one gets a different type of context. The one above got this analysis context. It's kind of the place where everything starts. We're initializing. Here's where you can register all the actions to kind of get started. Now that I'm in here and I'm doing some actual work, the context is a syntax node analysis context, and it's got different things on it. It has a cancellation token because my analyzer may or may not be run single-threaded. It may or may not. It may be running in parallel somewhere else. These are things you need to be considering, and keeping careful track of state. One of the reasons we did this action-based approach was so that you can nest actions and you can maintain state within those actions and keep it safe, right? So that you don't have to continually take locks. But it's something to be considering because if you're in the IDE, chances are we're running it asynchronously so that we're not blocking typing, right? So it's just something to be careful of. So passing cancellation tokens around is a good idea because somebody might type another character and your analysis might now not be interesting anymore, right? Okay. The node is here, the actual node that got returned, because we said we wanted syntax kind dot object creation expression. We know that's what it's going to be, so we're going to assume that. We get a set of options which are sometimes can be passed to for analysis. They're used for different sorts of scenarios, and then a semantic model which allows us to ask semantic questions at this point about nodes in the node or in the surrounding nodes around it. So and when I say semantic questions, I mean like, okay, I need to take that object creation expression, that new of immutable array. The first thing I need to do is look at the type of it and verify that it's actually a mutable array. That would be the sort of question, semantic question, I would go to the semantic model and ask. Is this actually an immutable array? Seems pretty simple when you think about it. So I'm going to assume this is an object creation expression syntax. All right. Now what I'm going to do is I'm going to try and this is starting to get a little bit. Well, first this is starting to get a little less productive than I'd like it to be because we're being a little speculative about it. I'm going to try and write this analyzer at debug time with edit and continue because I find that to just be more efficient. But first, let's put some better names up here before we dive into that. Let's give it a better category. It's not naming. We're calling this like API guidance. And then let's make sure that our resources make sense. I don't want it to be type names should be all uppercase, right? I want it to be use immutable array, or don't use immutable array of t, right? Constructor. Constructor, and we'll just make sure that everybody realizes this is a real thing. I'm not just running the one that I had on NuGet. No sleight of hand. We'll write the real thing. And I'll copy all these down here. Whoops. That's weird. What does this do? I'm just going to delete this all. Oh, I see what it did. I wasn't in here. Okay. Sorry about that. All right, there we go. And so now I'm just going to go ahead and run. Now, if you notice down there, the startup project is a v6. This is really great for debugging because I'm going to debug this against another instance of Visual Studio. I'm just going to have it running so that I can go and load some code up there and start playing around and hit my breakpoint. Okay. So F5, hopefully everything builds. Whoa. And we load another instance of Visual Studio, mind blown, Visual Studio, debugging Visual Studio. And this actually runs Visual Studio in another, what we call an experimental hive. Visual Studio has a way of kind of loading itself in another context, so it has a different set of extensions. So this doesn't get installed into my primary Visual Studio, it gets installed into a Visual Studio with this other set of extensions that includes the one I'm working on. Okay? If you're interested in, or if things ever get wonky, the best thing to do, oh, by the way, our breakpoint hit, hold on. The best thing to do if everything's ever get wonky with your hives, local app data, pro tip, local app data, Microsoft, Visual Studio. And in here, there's 14.0. That is 2015. That's the version number of Visual Studio 2015. That's my main hive. That's the one that runs when I click on the icon in the start menu. These are experimental ones. This is the one we're actually working in. You can see the date modified is today at 11:06 a.m. It was 1 minute ago when we compiled our extension and deployed it there. So if things ever get wonky, you can come in here and do things like delete the extension, delete the component model cache, which is the MEF cache for Visual Studio if things aren't loading right. So there are things you can do here to kind of fix up your world if things get out of whack. So pro tip, local app data, Microsoft Visual Studio. So we've hit our breakpoint. And the reason we hit our breakpoint was because an object creation expression was found. Right? Here's our demo fodder. It looks like this. It's not really much to it. And it was actually found, if you notice, this analyzer is running before, really, even before the semantic colorization in the IDE ran. Right? It's already trying to find out, is this thing bad? And so if I go ahead and step through, let's see. Yeah, I see that in fact this is the object creation syntax. I can look at it here. We can see what it is. And two-string it and see that, oh yeah, that's exactly the one I'm looking for. That's the node. Right? You can always two-string on a node in Roslyn, and it will give you exactly the source code that it was parsed from. Even if it had errors, it will always go back and show you the same source code. All right, so next up, we need to verify that that is in fact a mutable array of t. So I need to somehow figure out what type, how to use the semantic model to ask the question, what type is this? And then I have to go out and find the actual immutable array type and compare them. Are they the same? So let's get the immutable array type first. We'll call this immutable array type, because I am not creative today. And we're going to get to this by going back to an API. This is a very useful API if you're just trying to find types in the universe that are loaded. Go to semantic model, go to the compilation, and get the type by its metadata name. All right, and the metadata name of this type is system.collections.immutable.immutable array. Ooh, and then what do I put here? How do I say? It's not this, right? Because that's C#. That's not its metadata name. So in metadata, if you don't know, the way you do generics are encoded, their names are encoded in metadata was with a backtick, and then with the array arity, right? So the number of type parameters. So this would be backtick 1. And that should be the immutable array. Now, because I'm doing this at edit and continue time, let's just go back and step over it and make sure that worked. Hey, look, it came back with a symbol, a name type symbol of system collections immutable array, and you can start drilling into that and looking at the object model inside of it. All right, cool, that's cool. So let's go to the object creation expression. All debug time, all edit and continue. Edit and continue rocks. So let's ask that semantic model, hey, the type of this object creation expression, what is that? And so I'm going to put that in a variable called symbol info, and I'm going to go to the context again, go to semantic model, and say, all right, and the semantic model has all sorts of interesting things on it, things that we will not drill into here, things like analyze data flow, and all sorts of nifty things on here for asking semantic questions of syntax nodes. That's kind of how we built Roslyn. Instead of giving you what we would call a bound tree, or an annotated syntax tree, where everything, all the symbols and everything was already resolved in the tree, instead we give you an API that you can ask questions. What does this node actually bind to once the C# language rules have resolved over it? And so I'm going to do that. I'm going to call get symbol info. And that is going to be passed object creation, our object creation expression up there. Because that's going to give me back not the type, it'll give me back the constructor. So I'm going to drill into the object creation. I'm going to grab the actual type part of the node, the thing that's the actual thing that says immutable array of T. And we'll step over this. And let's see what we get. Hey, look. It's an immutable array of system.int32. We're actually looking at this source code, introspecting it, analyzing it, using the Roslyn compiler, .NET compiler to poke at the .NET compiler platform. So now I know it's a name type. What I'm going to do here is I know I want it to be a name type. So instead of putting this in a symbol info, I'm going to just say, we're going to call this our array type. And I'm going to get the symbol, and I'm going to assume it's a name type symbol. Okay? That's what I want it to be. We'll protect against it in a second. So there it is. It's my system.int32. So I just plucked it out of that symbol info. Now, if array type, now remember this is a constructed generic. It has an int in it already, but the type that's actually in the assembly is the one that's of T. So I need to compare. I need to get back from the one that's constructed to the open generic type, to the one that's of T. And so I'll do that by using a property off of the symbol here called constructed from. And this gives you the returns a type symbol that this was constructed from without its type arguments. If that equals the immutable array type, then we're going to report a diagnostic. One thing here is that if this happens to not be a name type symbol for some reason, and that is conceivable. It could be other types of things. It doesn't have to be a mutable array. It could be anything. If it happens to be, we'll throw here. And so I'm going to go ahead and use C#6 null conditional operator to make sure that I can just escape that null. So if it happens to be null, it'll move forward. Now that is interesting because that changes. Because this expression returned bool, so that changes this now to nullable bool. So I have to change the expression slightly. Say, if that equals true, then we're going to go ahead and report our diagnostic. And so I go to the context, I call report diagnostic, and then I create a diagnostic. And we'll say, hey guys, or well, actually we're going to pass in our rule. That's the diagnostic descriptor is defined for us already. It's right here. It's defined as part of the template, and it's filled in with those resources that we renamed a little bit ago. So we're going to put that here. And the location is the span I want to be squiggled. okay? And the span I want to be squiggled is actually the type. So we'll give it object creation, again, getting back to our expression, the type of it, and we'll call get location. And one more thing, I need to pass in, no, I don't need to do any more things. That's it. Okay, we have literally this much code. It fits on screen in 15 point with a bunch of other tool windows up. All right, so just to prove it to you, let's go back here. We'll step over. We report that diagnostic. I'm going to remove our breakpoint F5 so we can get to it. I come back here, and I should see a squiggle. As a bonus, we did it all with edit and continue. Now, the squiggle is a warning because that's a default, right? That's the default from the template. I could say, it says, create these as warnings by default. This is a particularly heinous one. I'm going to stop this and go back. It's a particularly heinous, transgression of using the immutable API. So we're going to say here, it's over in the rule itself, the default diagnostic severity should be an error, right? So that it squiggles red and it breaks your build. And so if you put this in a NuGet package or you put in a vSIG, or you put this in a NuGet package as a dependency in your project and it gets restored on build on your build server, it'll break your build. It's great. So let's write a fix. We've got a little bit of time. Yes, we've got enough time. We're gonna have to speed though. All right, so I'm gonna create a new code fix provider. And the way you do this is, it's very similar to writing an analyzer. Analyzers, you're given kind of this, but the difference is that analyzers, you're given the APIs as the compiler has baked them for you. It's already cooked them up, and so it hands over. Okay, I've got a semantic model now. It's all cooked up. I've done all the I need to do to resolve all C# language rules. Here you go. Here it is. In a code fix, it's different. It happens. It's user initiated, right? And so you kind of get a different set of APIs to work with it. So I'm going to call this. Actually, this is a terrible name because it's the thing we're going to send from. Is that we'll call it build code fix provider. We're going to send from a type called code fix provider. I'll go ahead and control dot to add that. And then I need to always remember to export it. Okay, and I give it a language that it's targeting. So that's going to be off of. There's a type of kind of a bag of language names in Roslyn called language names. And we want it to be C#. So this should be loaded now, or when it doesn't error, when we get to a certain point, it will be loaded in the IDE. And we're going to go ahead and implement that interface or the abstract class like so. I'm going to go ahead and now the first thing I need to do is tell it, here are the diagnostic IDs that it actually fixes. A diagnostic ID is that little number that appears on the left in the error list. It's actually totally a string. You can put a lot of things in there. And for this one, the diagnostic ID is, where is it? It's right up here. So I'm actually just going to, they make it a const, a public const, so I can actually call it right off of this. And we'll just return a new immutable array. Ha ha ha. Careful. And we'll just create one, passing in the diagnostic ID from there. Okay. Notice now this grays out because, hey, C# Essentials is installed and this can be turned into an expression bodied member, so we don't need to have all that boilerplate. I also like to put these on separate lines sometimes when they're long. Okay, now down at our method, this is where we're going to implement to actually register a code fix. This is going to do the actual transformation. Now, what we're given in our context here, this is yet again, it's a different context, the code fix context, is very different. We're given a cancellation token, the diagnostics for which this is being triggered, because a fix could fix multiple diagnostic IDs, there could be multiple diagnostics on the same line that apply, and so there's kind of a bag here. A document. Now, a document is analogous kind of to a Visual Studio document. Or it might not be Visual Studio if it's hosted somewhere else. Say you're on OmniSharp server or something like that. It might not be Visual Studio, but it's that notion of a file with a tree and a semantic model and all of that. You can actually, though, the document is also part of an immutable model, object model that can go up to, you can get to the project and to the solution. So you can do a lot with a document. This is the document it's triggered in. You also get a span, which is literally the text span of the that it's being triggered off of, okay? So that's that location that we gave in the analyzer. Where do I want the squiggle to appear? That's going to be right here. It's a span in the editor, a start and an end. So what are we going to do? We know we need to get back to that object creation expression. So the first thing I'm going to do, though, because implement abstract class does not do this for us, and I'm sorry, this needs to be async, because this is going to run potentially, in the background, showing up the light bulb in Visual Studio. It could run in all sorts of different ways, and so we do this in an async manner. And the document itself also supports several async APIs. The first one I'm going to do is I'm going to go get the syntax root from the document. And the syntax root is, from context.document. The syntax root is literally the root node of the entire syntax tree. And it's async because it might hit the disk. It might be that this document hasn't actually been read yet. It might have to go to the disk, do a parse, do all sorts of things. And so we do this asynchronously, and we await that so that we're not blocking the UI thread while things might be happening like that. So just to be aware, and I pass in my cancellation token in case while that happens, somebody types another character or something like that. Now that we've got the root of the tree, we can take the span that we were given and find the node that we're interested in. And so I'm going to do that by stringing together a couple APIs. Object creation is what I'm going to get. I'm going to go to the root. I'm going to find node. I think I'm going to, I got tree, not root. I said root. I didn't do root. There we go. I'm going to get the node. Find node. Pass in my span here. And that span is going to find me a node. It might not be the node I'm looking for. It might, because remember, we actually squiggled the type, not the whole object creation expression. And the object creation expression is the one I need to replace. I need to replace the new keyword and the parens at the end. So we're going to go and use an API to kind of navigate through. We'll find the first ancestor of this in the tree, or itself, of type object creation expression syntax. So just go find it for me. Okay. And that should be there. Now, if we found that, we know that we're being called here because the analysis happened. We know that it's correct, right? We know that we are in a condition where they're using a mutable array of t. So we can go ahead and perform the transformation. I'm going to go ahead and register a code fix right here. And the way you do this is you construct a code action. The code action is kind of a representation of the change itself, okay? The thing that actually transforms one thing to another. And so I'm going to create that, create a code action. Okay, and we'll give it a title like, hey, use a mutable array of t.empty, fool. I would love it if all of my fixes said that. And then we have a very complicated looking delegate type. Sorry, we love lambdas, don't we? It takes a cancellation and it returns a task of document. Again, because this is going to be asynchronous, the transformation from the old document into the new document needs to also be considered to be asynchronous as well. And so it's going to return a task of document. So I'm going to pass in here, I'm going to name my cancellation token C, and do fix, we'll call it. I'm going to pass in, let's see, my object creation expression. I'm going to close over that. And I'm also going to close over the document and my cancellation token. And I think that's all I need to do. Now I'm going to generate my method. Again, we have to make it async. What did I do wrong? Oh, I don't have an extra, is that right? Oh, yes. Sorry, I forgot to actually pass the diagnostic. It likes to know which diagnostic you're providing a fix for. There's only one in here, so we'll provide that. Okay. So now, performing the fix, I've got the object creation expression. I'm going to construct the immutable array of t, or of int, or whatever it's actually constructed from, whatever the constructed generic is. I'm going to take that and put .empty on the end. Now, I know that in the C# grammar, well, we can just try it out. I know in the C# grammar that that's actually a member access expression. I can verify that by bringing up the syntax visualizer again and just writing some code and looking at it. right here. It's a simple member access expression is what I need to construct and replace the object creation expression with that. So we'll go in here. So fixes, as you can see, are a bit more complex. All right, go to create our member access expression. I'm going to use, I'm going to use a new API that we've just added called the syntax generator, which is a great way for generating syntax nodes in a language kind of agnostic sort of way for various types of nodes. And one of those that is easy to create from it is, in fact, the member access expression. So I'm going to go ahead and add this guy. Come on. Give me something. There we go. I'm going to say get generator for a particular document. And so this gives me a way, this generator object, to add all sorts of things, to make syntax changes to a tree, to actually make transformations. Super useful for a lot of different tasks. And the one I want is this one, member access expression. And what it does is it takes a node and a name. The name is going to be the member that's going to be dotted into. The node is going to be the object creation's type, right? So I can actually just pass in here object creation dot type, pass in the name empty, and now I have the node I need. And so at this point, there's a fairly mechanical process of say, let's go back. We're going to get the root of the tree again. In fact, I'll just copy and paste because we have that innovation in Visual Studio. Oh, but I need to change these. Hold on. Because I passed the document specifically, and I gave it my own cancellation token called C. All right, so we get the root, and then we're going to create a new root from that root, by calling replace node. And we're just going to replace in the tree object creation with our member access. And now we have a brand new tree back. Roslyn transformations of syntax trees are done in an immutable fashion. These are immutable APIs. And so you think of it like string.replace. I make a change, I get back a new string, right? It's the same thing with the trees. And then our last thing is we're going to go document, return from our document, a document with that new syntax root. And now let's, fingers crossed, let's run. I may have done this in time. Okay. Demo fodder. Here we are. It's an error now, like we said. I come in here. I'm not seeing the code fix. And I bet I know why. Remember when I opened that folder earlier and I said sometimes you got to kick things? Let's delete the component model cache. So that means now it's going to recreate the mef cache. I believe what happened was the binary didn't change enough that it realized that there was something new in it, right? And so Visual Studio didn't really refresh it, and so now there's a light bulb there. And it says, hey, use immutable.t empty, fool. And sure enough, it works. You got the preview for free. You got everything for free. So I want to thank you guys. We are actually at time. That was a lot of fun, rushing through and constructing something off the top of my head, almost quite literally. I built that yesterday. So there's a few related talks. Obviously, these are over. But these will all be online to check out. Do leave an evaluation. And I am going to be up here to take questions. We're kind of out of time. If we want to use the microphones for a bit, please do so. If not, you can shout it out, and I'll try and repeat the question. But I hope you guys enjoyed it.